So for the electrical test, like we said earlier, there are a few of them that we need to carry out on the transformer. So the first, on the bolted connections, we want to carry out resistance tests. Okay, so we can use any low resistance meter, milliohm meter, place one of the probe here. Okay, like on this now, we can place one of the probe here and then probe this end. So if we do it as such, that will give us the resistances between these terminal lugs, okay, and the conducting part to of that is feeding the transformer winding. Whether this could be the input or output. Okay, this is the output of the transformer. So remember, we want as low as possible resistance between this lug and the terminal to which it is connected. So that is what we are actually testing, whether this lug is making proper connection with the terminal. Okay, so as the resistance is going up, we know that that can cause problem, because that can be a potential hotspot during operations and thus a point for potential failure, apart from the fact that it can reduce the efficiency of the equipment. So we want to test the resistances between this lug and the terminal to which it is connected. So we can do it for all the lugs that are connected to that particular terminal. We can do it for this, put one of the probe here and one here. Okay, put one of the probe here and one here, or we can put the probe here and then put it here. That will test the resistance between this lug and the terminal. Then we can leave the probe here because that's the terminal connection. Okay, and then put it here. That will give us the resistance between this lug and the terminal, and then put it here. That will give us that of this. So that is what we want to do to ascertain that the resistance is as low as possible. Zero. If it is zero, the better for us. So we also do insulation resistance test. Okay, so you can check the description below for a link to insulation resistance test training if you are not too familiar with it. So we'll do the insulation between phases, and then between the windings and the ground. So if the unit is connected inside, tethered inside and starred inside, of course what we'll be measuring is between the windings and the ground. So that is what we'll be looking at the end of the day. So we want to ascertain that the insulation of the transformer, okay, is as required. So we apply voltage according to what the manufacturer actually recommended, or what is specified in our facility. So that is what we are going to be using. But in the absence of that, we can use this as a guide. Okay, so these are some of the ratings in volts of the transformer between 0 and 600, 600 and 5000, then greater than 5000. So the voltage that we have to inject or apply between the areas that we are testing the insulation, if it is between winding and ground, so we place one on any of the winding since it is connected inside, and then the other probe to ground. Okay, so we apply 5000 volts. If it is this range, we apply 2500. If it is greater than 5000, we apply 5000 volts. So here are the recommended acceptable insulation resistances. Anything less than this will call for more investigation. So for liquid filled transformer, those low voltage transformer, 100 mega ohms. For up to 5 kV, 1000 mega ohms. More than that, we need to be more than 5000 mega ohms. Therefore, dry type transformers, this is the acceptable insulation level that we should be looking out for. So anything below that, it cause for further investigation. They will also perform the turn ratio test. So this one will give us an idea of the transformation ratio of the transformer. So we'll do it on all tap points, okay, or position of the tap changer. So if it is the manual tap changer, of course, that means that we'll go manually and do the tap changing, okay. Then we'll also perform the power factor or dissipation power factor test. So this is actually testing the insulation between both windings, the primary and the secondary winding, and then between each of the windings and the ground, between the primary and ground, secondary and ground. So that is basically what we are looking at. So you can also look at the description below for a link to our earlier training on power factor testing or turn data testing on transformers. So here are some of the expected results if none is recommended by your manufacturer or specified for your facility. So you can also use this as a guide for new transformer and reactors 0.5%, for new distribution, that is new distribution transformer and regulators 1%. Then transformers that have been worked on or reactors that have been worked on 1% is also okay. Okay, so this we use them as a guide. So we also do the same for the bushings. Okay, it is the same thing. So basically, why this is important, if we have cracks on the bushings, this power factor test or dissipation factor test will expose such cracks. So we want to check, we want to carry out a power factor test on the bushings. Okay, so what we are looking at is the insulation between the conducting part and the ground, okay, and the external part of the bushing, so to say. So the next that we will do is the excitation current test, and we want to carry out the excitation current test in accordance with the published data, that is the manufacturer recommendation of the transformer manufacturer. So once we do that, if the test result is as specified, of course, that means the transformer is still fit for use. So the next test that we are going to be doing also is the winding resistance test. That is, in the transformer, the primary and the secondary, we have 3 sets of windings. And on each side, those 3 sets of windings on each side, their resistances are expected to be the same. So like in this case now, it is connected in delta, okay, which means if you are probing between here and here is a coil, a winding, between here and here is a winding, between here and here is a winding. So this is a start point now. Between here and here is a winding, between here and here is a winding, here and here is also a winding. So when you probe this end, you are testing the winding of the first phase, between here and here the winding of the second phase, here and here the winding of the third phase. The resistance, I mean to say, not winding. If you probe between here and here, you are testing the resistance of the first phase, here and here the resistance of the second phase on windings, and then between here and here the resistance of the third phase on winding. So you can also check the description below, okay, for a link to winding resistance test on transformers and electric motor. So the resistances of each of the winding on the primary side is expected to be the same. On the secondary side, they are expected to also be the same. So if there are discrepancies, you want to do further investigation to determine why we have such discrepancies. Okay, so this is what we are actually describing: the start point, the neutral between the neutral point and line 1, you are looking at this winding. Between the neutral point and line 2, you are looking at this winding. Neutral point and line 3, you are looking at this winding. While for the data connection, between line 2 and 3, you are looking at this winding. Between line 1 and 2, you are looking at this winding. Between line 1 and 3, you are looking at this winding. Okay? Though some have argued that if you are testing between line 2 and line 3, that is, if you are testing between two lines, okay, whether line 2, 3, 1, 2, or 1, 3, some are arguing that they will have this resistance C in parallel with A and B. So what we are actually testing is the resistance, okay, of here and here, all the resistances between these 2 points. That is for C, A, and B in parallel with A and B in parallel with C. Okay, so however you look at it, since the windings are the same thing, it means that when you are taking your measurements from any of the two terminals, you are expected to have the same result. So once you have discrepancies, that should be our concern, not necessarily the value, okay? But we expect the values to be the same since the configuration is the same thing. So the next, we want to look at the core to see that it is not shorted. If the grounding strap is accessible, we can disconnect the grounding strap, okay, and test for the insulation between the core and ground, and between the core also and any of the terminal connection if it is accessible. If not, we can actually let this go. Okay, so the percentage of oxygen in the blanket gas, we also want to test it if we have a blanket gas in the transformer. So the reason for this is that, you know, there is a level of oxygen concentration that we'll get to that can cause the ignition of your transformer oil. So the percentage of oxygen, we want to maintain it at the most minimal level as much as possible. So we'll take a sample of the oil from the transformer, and then we can test the oil, that the sample that we collected. We'll test it for the breakdown of dielectric strength. Okay, so the dielectric strength of the oil is the voltage at which it starts conducting between these two electrodes, and it actually depends on the spacing, okay, of the electrode. So you adjust the spacing, and then the result should be we should get a result that is acceptable at the end of the day. The acid neutralization test, okay, to get the acid number, we'll carry out the test. They will test the specific gravity of the oil. Of course, we know that the specific gravity will affect the viscosity of the oil and thus the cooling effect of the oil, and also even the dielectric strength of the oil. Interfacial tension, we check it, and then the color, we also look at it. Then the condition visually of the oil, we'll look at it. Then the amount of water that is contained in the oil, we also check it, and then the dissipation factor of the oil, we also check it. So all of these tests, we'll do them according to those standards that you are seeing on the screen. Okay, so that is what we want to do, and we want to ensure that they meet the right specification. So the dielectric breakdown test, if we do not have any that is specified by the manufacturer or in our facility, okay, we can use this as a guide. So for the dielectric breakdown test, for mineral oils, then below 69 kV, this is the breakdown voltage, okay? that is acceptable. Are we getting it? So it should not broke down below this voltage in kilovolts. Then the dielectric breakdown, if the distance between the electrode is 1 mm, this is acceptable. If it is 2 mm, this is acceptable. Okay. Then the interfacial tension in Newton meter, okay, should also not be below this. Okay. Then the neutralization number, that is the acid neutralization number. These are some of the recommended values. Then the water content, these are some of the recommended values for different voltage levels, as you can see. Then the power factor, these are some of the recommended values. Okay, the color and the condition, okay, of the oil. So these are some of, you can use this table as a guide during your inspection and testing of the transformer. So for silicon insulated liquid in new transformer, silicon insulating liquid in new transformer. So these are some of the acceptable values, as you can see, for those parameters. So we can also test the transformer oil for dissolved gases. So those dissolved gases, after analysis, will tell us much about what is happening within the oil. Okay, so carry out that dissolved gas analysis to ascertain the integrity of our transformer.